When we left off last Thursday, we had just started talking about graphing. And so what I have up here is this is actually a page. I've got 10 equations on here that we're going to graph. We're going to start out just by graphing a couple. I'm going to do number 1 here and maybe number 4. And I'm going to have you guys do the others, just in your notes. Obviously, I realize you don't have the page in front of you, but you can sketch it out in your notes when you need to. So for number 1 here, you'll notice I gave you some values for x to try. So what I'm asking you is, with this equation, y equals 3x minus 2, what is y when x is a negative 2? So what that means is we come up here and we replace the x with a negative 2. So that would be 3 times negative 2 is what? Negative 6. Minus another 2 would be negative 8. So that gives us that ordered pair, negative 2 comma negative 8. So that means from the center of our graph, negative 2 for x would be right here, right? Negative 8 for y would be down here. So that's the point that's described by negative 2, negative 8. Next, it's asking if x is negative 1, what's y? So now I put negative 1 in here instead of the negative 2. So now it's 3 times negative 1 is negative 3. Minus 2 more is negative 5. Negative 3 minus 2 is negative 5. So that gives us the ordered pair negative 1, negative 5. So again, for the x, negative 1 is right here. For y, negative 5 is right there. So that gives us that point right there. If x is 0, now I put 0 in here. What's 3 times 0? 0 minus 2? Negative 2. Gives us the point 0, negative 2. So for x, 0 is right there. For y, negative 2 is here. So that's our point right there. Now, does anybody have questions as to where these values for y are coming from? How I'm getting those? I'm just taking my value of x, putting it in the equation here for x, and doing my order of operations to figure out what y has to be. So now, if x is 1, I put 1 in here. What's 3 times 1? 3. Minus 2 is 1. So that gives me the ordered pair 1, 1. X is 1 and y is 1. So from the center here, x is 1 there, y is 1 there. That gives me the point right there. But you've probably already got an idea of what shape this is. Anybody want to guess? A straight line, yes. But let's go ahead and do the 2. We're going to put a 2 in here now. What's 3 times 2? 6 minus 2? 4. So that gives us the ordered pair of 2 comma 4. So from the center, here's x is 2, here's y is 4. That would intersect right there. So we draw our line through it just like that. Any questions as to how I came up with the points on here? No, x is 2, y is 4, gave me that point 2 comma 4. So what I want you guys to do is number 2 here. Fill in the table, plot the points, and figure out what it looks like on the graph. Okay, so for this one, did you end up with something that looked like this? How many of you had a line that looked like that? 1, 2. Didn't get there yet? Okay. So at negative 2, it would have been 8. Negative 1 would have been 7. 0 would have been 6, 5, and 4. That's what you're getting? Okay. So let's start out with this. Anybody have questions as to where these numbers come from? Okay. So then from those numbers, we get our ordered pairs. Put the x coordinate first, -2, and then the y value second, 8. So that would be -2 and 8 right there. So it would be -1 and then 7, so -1 and 7. So you go -1, +7, that's right there. And so on. And then you can just extend it through because you know it keeps on going forever in both directions. That's why we put the arrowheads on the end of the line. Now together I want to do number 4. Number 4 down here, you'll notice I strategically chose some points for you to use. A couple of them got cut off, but that's okay. We'll go from here. So anyway, if I use -6 for x, so I put in -6 there, plus 6. What's -6 plus 6? 0. What's the square root of 0? 0. So that's going to give me a point at -6, 0. So -6, 0 is right there. Anybody having problems locating these points on the graph once they get the coordinate? Okay, so the x is always the side to side, and the y is always up and down. Next we have x is -5. So if we put -5 in here, what is a -5 plus 6? -5 +6 is going to be +1. What is the square root of 1? 1. So that gives us the coordinate -5, 1. So here's -5, there's +1 right there. If x is 2, or -2 I should say, put -2 in here. What's -2 plus 6? +4, and what's the square root of 4? 2. So that gives us -2 and +2. So here's -2, +2 right there. And what if x is 3? If I put a +3 in there. Yeah, 3 plus 6 is 9, and the square root of 9 is 3. So that's going to give us the point 3, 3. So 3, 3 right there. So with those points, we can get an idea this graph is going to look something like that. Now you'll notice I put an arrowhead on this end, but I did not put an arrowhead on this end here. Can anybody tell me why? No, it's not because it's not straight. Well, okay, yeah. It's saying we can only go in one direction. Up here, there was an arrowhead on both ends because this would go forever in both directions. Down here, if I went below a -6, what happens? Well, if I put a -7 in there, what's -7 plus 6? -1. What happens if I try to take the square root of -1? Calculator says, right? It gives us an error. I cannot put any number smaller than -6 in here, or I'm going to be taking the square root of a negative. So I cannot go below that -6. So that's why it stops there with no arrow, because I can't keep going in that direction. That's something called an asymptote. Not a word you need to know, but it's something you'll hear me say. This is one form of an asymptote. That just the line is stopped there. It's a limiting asymptote. You just can't keep going past that point. Number 3 over here now does not have an asymptote, by the way. That one does keep going forever in both directions. I'm going to have you try to graph that in your notes. See if you can make that work. I'm going to do the first number with you here, the -2. So that's going to be a -2 squared, placing the x there, plus 2 times, I'll put -2 in here, and then plus 1. So -2 squared is a +4, plus 2 times the -2 is a -4, and then plus 1. What is 4 plus -4? 0. Plus 1 is 1. So we get a point there at a -2, comma 1. So -2, 1 is right there. So I want you guys in your notes to plot the other 3 points. I give you x of -1, 0, and 1. See what you come up with. Okay, so let's take a peek here. So now when x is a -1, I put -1 in here for x in both spots now. What's -1 squared? +1. 2 times the -1. -2. And then we still have the plus 1. So what's 1 plus -2? -1 plus 1 is 0, giving us the point -1, comma 0, which is right here. -1, 0 would be right there. How many of you got that first point right? The negatives get you? Remember, you got to put parentheses around the negatives, especially when you square it, but it's easiest if you do it almost every time, pretty much. So now if it's 0, if I put in 0 here, what's 0 squared? 0. What's 2 times 0? 0. 0 plus 0 plus 1 is 1. So that's 0, 1 is that point. So 0, 1 is right there. So now we have +1. We put a +1 in there. What's 1 squared? 1. What's 2 times 1? 2. What's 1 plus 2 plus 1? 4. So we get the point 1, 4. So here's 1 and 4 right there. How many got that point right? Okay. Now if we look at this, we know it's not a straight line, but we're not necessarily sure what shape it is. Bless you. So a lot of times when we do these graphs, we use what we've already done. I mean, I just chose these points at random to get you started. But sometimes the points we use aren't enough to figure out the shape of the graph. So what we do is we plot a few points, and then we look at the graph and we ask ourselves, where do we need more information? Like right now, I would say it's pretty clear that this side is going to look something like that. But over here, I could use a little more information. So if I knew where this point was up here above x equals -3, if I had a point there somewhere, it would help me define that other side of that graph, wouldn't it? So let's use the value of x equals -3. If I put -3 in here, what is -3 squared? +9. What is 2 times the -3? -6. So now +9 plus -6 is 3, plus 1 is 4. So we've got -3, comma 4. So -3, 4 is right there. Now if you're paying really close attention, you'll notice this is symmetrical. From this point here, which is actually called a vertex, the right side and the left side are the same as they go up. Remember we called that a parabola. You don't need to know that term, but that's very common when you have an x squared in the equation, that you're going to get that U shape like that. Any questions on that? You'll notice once again I did put the arrow on both ends. This does go on forever in both directions. There's no limits to it. I want you to take a few minutes and try to graph these two. See what you come up with. Okay, so in the first one over here, if x is -2, what's y? -3, good. If x was -1, what's y? 0. If x was 0, what's y? 3. If x is 1, y is 6. And if x is 3, y is 9. So my first point, -2, -3, would be right there. I'm going to put that in red. Where's my next point? What's that? Oops, I'm sorry, that's wrong. That should be a 12, isn't it? Sorry. That was my fault. Okay, so there's my first point's at -2, -3. Where's my second point? -1 and 0. That's right here. Where's my next point? 0 and 3, which is right there. Where's my next one? 1 and 6. And 312 would be way up here off the graph somewhere, right? This forms what shape? Straight line. Something like that. How many of you came up with that? Nice straight line. Okay, good share of you. That's good. Does number 6 come out to be a straight line? No, it does not. Number 6, if you enter it in the calculator right, 2 to the power of -2 is 0.25. 2 to the power of -1 is 0.5. What's anything to the power of 0? 1. 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So we have -2 and 0.25 is right there. -1 and 0.5 is right there. 0 and 1, 1 and 2, 2 and 4. What we get is a curve. Looks something like that. How many of you got a curve that looked like that? Oh, that's kind of a tough one. Those negative powers, if you don't enter them in the calculator right, they'll mess you up. Now this is another one that actually has an asymptote. This line right here, the x-axis, is an asymptote because y will never be less than 0. It'll actually never equal 0. The further negative x gets, y is going to get smaller and smaller and smaller, but it'll never equal 0. This is 1/2, this is 1/4, it would be 1/8, 1/16, 1/32, 1/64. It'll keep getting smaller. It'll cut it in half every time, but it's never going to get to 0. Now, there's a couple others here. I'm going to have you try those, and that'll be the last one. There's 2 more down here, but these are pretty simple. We'll kind of do those last 2 together. I'm going to have you try these 2, though. 7 and 8. See what you come up with, and then we'll move on from there. Okay, so for the first one, we have -2, -9, which would be right down here, right? -1, -2, correct? So right here. 0, -1, which is right there. 1, 0, which is right there. And 2, 7, which is right there. So we get kind of that S shape like that. How many of you came up with that one? Okay, good. Okay, so if you think about it this way, here's your origin, that's 0, 0, right? Well, to move to x equals 0 for the 0, negative 1, to move to x equals 0, you're already there. So you just stay there. To move to y equals negative 1, you just move down 1. That's right there. For this one, this is 0, 0 again. To move to x equals 1, you move over to here. Y equals 0, you're already there. You can think of it as starting at the center and moving from there. Like this, negative 2, negative 9 means you start at the center, you move over negative 2 for the x, and then negative 9 for the y. 2, 7, you start at the center, you move over to 2, and then up to 7. Number 8, does anybody think they got number 8 correct? That's good. Number 8's a really tough one. Now, very, very few students get this one correct. If I put in negative 8, of course, 8 divided by negative 8 is negative 1. Put in negative 4, that's negative 2. What's 8 divided by 0? Try it in your calculator. It gives you an error. 8 divided by 0 can't be done. 8 divided by 4 is 2. 8 divided by 8 is 1. So what you get if you plot points here is you get something that looks like this. Can't go through 0, so it starts over here. Like that. Two separate curves that don't connect. Again, we talked about that asymptote. There's an asymptote here because x can never equal 0 because you can't divide by 0. If you followed this graph, it would get closer and closer to 0 as it went up, but it would never equal it. Same here. As this goes down, you get closer and closer to 0, but never equal it. A lot of people don't realize a graph can be broken into two separate curves. This is one that can't. It has to be because it can't go through 0. What a lot of people do is they try to do something like this, and then they jump and connect it like that. How many of you tried to do that? Yeah. And it's natural to try to do that. It doesn't work. Okay, these last two down here, I'm just going to do them really quick for you. Come on. Just so you have them down. So y equals 4 times x squared minus 8. If I put in negative 2, negative 2 squared is 4. Times 4 is 16. Minus 8 is 8. So it'd be negative 2, 8 is right there. If I put in negative 1 squared is 1. Times 4 is 4. Minus 8 is negative 4. So negative 1, negative 4 is right there. If I put in 0, what's 0 squared? 0. What's 0 times 4? 0. Minus 8 is negative 8. So 0, negative 8 is down here. If I put in 1, what's 1 squared? 1. 1 times 4? 4. 4 minus 8? Negative 4. Right? So positive 1, negative 4 is right there. If I put in 2, 2 squared is 4. 4 times 4 is 16. Minus 8 is 8. Right there. We get that parabola, that U shape again. I know I went through that kind of fast, but you can go back through the video and slow that down if you need to. So over here, 3/4 times x minus 4. If I put in a negative 2, 3/4 times negative 2 is a negative 1.5. Minus 4 is a negative 3.5. So negative 2, negative 3.5 is somewhere in there. If I put in negative 1, well, 3/4 times negative 1 is negative 3/4. Minus 4 is a negative... Something went wrong there. Yes, I did something very wrong there. Let me try that again. Negative 2 times 3/4 is a negative 1.5. Minus 4 is a negative 5.5. That looks better. That's down here. 3/4 times -1 is a -0.75 minus 4 is a -4.75, which would be right here. Putting in 0, 3/4 times 0 is 0, minus 4 is -4. Right there. Gives us a line. It's going to give us a line going across here like this. What do you think? Not so bad? Okay. Now here's what I want you to really think about. There are 4 equations on here, on this worksheet. Number 10 is one of them. Come on. That gives us a straight line. Number 5 gives us a straight line. And equations 1 and 2 give us straight lines. I want you to think about what is different about those equations compared to the other ones that don't make lines. So let's list them out. We had, that ain't gonna work, is it? You've got them written down in your notes. You guys can just tell me. The ones that make lines. What do we have? Y equals 3x minus 3. We had y equals 6 minus x minus 2. Okay. 3x minus 2. Then what was number 6? 3 plus 3x? Is that right? Number 5, sorry. And then number 10 was y equals 3/4 x minus 4. Those made lines. Ones that did not make lines. Number 3 was y equals x squared plus 2x plus 1. Is that correct? Number 4 is y equals the square root of x plus 6. Number 6, y equals 2 to the power of x. 7, y equals x to the 3rd minus 1. 8 was y equals 8 over x. And 9, y equals, what was that, 4x squared minus 8. Is that right? So we had these 4 equations that made lines and these 6 that did not make lines. Do you see any differences between them that stick out? Powers is one of them. But to be more specific, one of them is powers on a variable. Here we had x squared, here we had x to the 3rd, here we had x squared. This is in fact a power, by the way. A square root is a power. It's a power of 1/2. So those 4 equations display that powers can cause it to not be a line. What else do we see? We've got 2 more up there. What's going on in those? Well, here's a fraction. Yes, that's very important. There's a variable in a denominator. Along with that, it could also be, remember, fractions can be thought of as division or dividing by a variable. They're kind of the same thing. A variable in the denominator is dividing by a variable. This last one right here, it deals with powers, but it's not a power on the variable. What's going on there? The variable is in the power. The variable is the power. Now, all of these technically have to do with powers. I mean, this one here, a variable in the denominator, you could actually think of this as being y equals x to the power of -1. We went over that negative powers a little bit. That's actually reciprocal. That's dividing by it instead of multiplying by it. But we're going to list it out just separately like this for now. These three things here are the three things that keep an equation from forming a line. I usually call them the three don'ts of linear equations. But if an equation has any of those three things in it, it will not form a straight line on your graph. So if I give you this equation, will that one form a straight line on the graph? Why not? Well, where's the power? Yeah, the power's not on the variable, is it? It's on a 4. That's just y equals 5x plus 16. The power only affects it if it's on the variable. How about there? That is a line. Very good. How about that one? No, we're dividing by the variable. That's the same as saying 7 over 9x. We cannot have x in the denominator. We cannot divide by an x. How about that one? Bless you. Yeah, that's just y equals 21x plus 3. That is a line. How about that one? No, why not? Yeah, it's x to the third. There's a power on the variable. And how about that one? We're used to seeing y equals 7x minus 2 is okay, but this is 7 to the power of x. So no, that is not a line. How about this one? Y equals 4. There's no powers on the variables, but there's no x, is there? Remember, we went over this last week. 1, 2, 3, 4. Here's where y equals 4. Here, 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 here. That's just a flat line across our graph at y equals 4. So that is a line. There's no powers or anything like that. How about x equals a -2? What's that look like? Is that a line? Yeah, it doesn't have our powers or anything. That's just going to be at -2. It's going to look like that. It's a straight line. It just goes, it's vertical. We're going to ignore these two for right now because those are special cases. The y equals a number is a flat line, a horizontal line, and x equals a number is a vertical line at that number. We're going to look more at these other ones for just a minute and see what happens to them. So if we have, I'm going to put a graph up here for a minute. And we're going to start out with the simplest form of linear equation we can get. Y equals x. There's no powers, no dividing by x. That's as simple as we can get. Well, if x is -2, what's y have to be? -2. If x is 0, what's y have to be? 0. If x is 3, what's y have to be? 3, right? So we get this straight line, of course. It's through our origin, through the center of our graph, and it goes diagonal corner to corner across the graph. You could say it goes at a 45-degree angle if you wanted to. That's the simplest form of linear equation we can get. We could make it a little more complicated. What can we do? Remember, we talked about building equations. What can we do to make this more complicated? Well, to x, maybe we'll add something. Let's do like y equals x plus 2. Now, if x is 0, what's y have to be? 2. If x is 3, what's y have to be? 5. If x is negative 3, what's y have to be? Well, negative 3 plus 1 is, or negative 3 plus 2 is negative 1. We get that line right there. How does it relate to the original line? It's parallel, yeah. It goes across the graph at the same angle. It's just been moved up 2 spots, hence the adding 2. So now just a wild guess here. What do you think would happen if we did y equals x minus 3? Yeah, it's going to be parallel, and we're going to move down 1, 2, 3 spots right there. If we look at that, if x is 0, 0 minus 3 would be negative 3. That makes sense. If x is 3, 3 minus 3 would be 0. So 3, 0. That makes sense. It does fit the line. If I drew it better, it would fit even better. Okay. How about this? So we've added or subtracted. That just moves the line up or down so it doesn't go through the center anymore. What if we did this? Multiplied the variable. Y equals 2x. Well, now if x is 0, what's 2 times 0? Still 0. It's back to going through the center. That's called the origin because it's the 0 point or the beginning of both number lines. It's also where all graphs start, is at the origin. They move from there. If x is negative 2, what's y? Well, what's 2 times negative 2? Negative 4, so down here. If x is 1, what's y? 2. 2 times 1 is 2. So we get a line. It goes back to going through the center again, like we said. How does it relate to this original line? It's steeper, right? It goes at a steeper angle. So how do you think we'd make something go flatter across here? Y equals x divided by 3, maybe? If multiplying makes it steeper, dividing would make it flatter. Now, usually, instead of doing dividing by 3, we would do this. Y equals 1/3 times x. Multiplying by 1/3 and dividing by 3 are the same thing. But when we look at graphing, this is simpler to think about. So now, if x is 0, what's 1/3 times 0? Still 0. What if x were 3? What's 1/3 times 3? 1. So 3, 1. What if x were negative 3? It would be negative 1, right? Like that. So it does indeed make the line flatter or shallower when we divide or multiply by a fraction like that. So we've moved it up and down. We've made it steeper or flatter. But so far, all of these, as we move from left to right, go up. How do you think we would make it go like this? Multiply by a negative, like that. So now if x is negative 2, negative 2 times negative 3 is a positive 6. X is 0, negative 3 times 0 is still 0. If x is 1, negative 3 times 1 is a negative 3, like that. So it does indeed go down. So really, when we're talking about lines and these linear equations, there are only 2 things that can happen. The variable can have something multiplying it and then something added or subtracted to it, like this. What did we say this did when we added or subtracted? Moved it up or down, right? That's what's called the Y-intercept. What it does is, we said all graphs start at the origin, but they get moved up or down from there. It takes the beginning, it tells us where our graph begins. Most graphs, well, all graphs start at the origin, but that's telling us that this graph You're going to go start at the origin, you're going to go down 3, and you're going to start there for your graph. It's called the Y-intercept because you're going down 3 on the y-axis. Remember, this is your y-axis here. So that's where you start on that y-axis. This number we said describes the angle or steepness of the line. That is referred to as the slope. Now the slope is actually a fraction, where the numerator describes what's called the rise. That's going how far we go up or down. And the denominator describes the run. That's how far we go from left to right. So rise can go up or down. Run always goes left to right. So when we go to graph this, the -3 means we start from the origin. We go where? Down 3. So we're going to start right there. The 2 is our slope, telling us that we're steeper. I mean, a 1 would be a 45-degree angle. So we know this has to be steeper like that. But we said the slope's always a fraction. Right now it's just a 2. How do we make it a fraction? You put it over 1. The top number we said is the rise. So from this point, we established this is the starting point of our graph. We're going to rise how much? 2. And then we're going to run how much? 1. Because the bottom numbers are run. So there's a graph, just like that. So if I give you y equals 3/4 x plus 2, where does this graph start? From the origin, where do we go? Up 2, right there. So that's where this graph's going to start, is right there. We got that from the +2, the +2. What's our slope? That's the number that multiplies the x. That's 3/4. Remember, the top number is what? Rise. So from this point, we're going to rise how much? 3. 1, 2, 3. So we rose to there. What's our run? The 4. So we're going to run 1, 2, 3, 4. Right there. And our line goes through those 2 points. Now at that point, if we're not comfortable drawing in our line yet, we could do our slope again, up 3 over 4, and get a second point if we wanted to. So for this graph, where's it going to start? Now from the origin, we go up 1 because of the +1. From there, what do we do? That's the slope of -2/3. Remember, up here we said the rise can either go up or down, but the run always goes left to right. So what do you think the negative goes with, the rise or the run? The rise. The run will always be positive. The rise is negative. So from this point, we go down 2. We rise -2. I shouldn't make a point there, though, because it's not a point. Sorry. I'm back. There we go. So from that point, we go down 2 for our rise. And we run how much? 3. 1, 2, 3. Right there's our second point. If we wanted to, we could go down 2 and over 3 again. Get a third point if we needed it. There's our line. Where's this one going to start? I move the order of things around a little bit, but the numbers still mean the same. What number is really being added or subtracted here? 5. The negative 3 is multiplying the x. The 5 is being added or subtracted. So we start at, from the origin, we go up 1, 2, 3, 4, 5. That is where we're starting. The slope is the negative 3. We make that a fraction by putting it over 1. So from this point, how far do we rise? Do we go up 3? No, it's a negative, so we got to go down 3 to here. And then we run 1 to there. If we wanted to, we could go down 3 over 1 again if we wanted to. And if I were better drawing, this makes a straight line right through it, like that. Where does this one start? Careful. The negative 3. Remember, the slope, it's always easiest to find the slope first. The slope multiplies x. So the 5/2 multiplies x. That's our slope. The other number then is our starting point, our y-intercept. So negative 3 means from the origin we start out down 3. Right there is where we start. So now we have that slope of 5/2. So from here, how much do we rise? 5, 1, 2, 3, 4, 5, and we run 2 right there. What do you think? Tomorrow we will look more at this, and what if the graph isn't in a nice neat little form, or the equation isn't in a nice neat little form with this? How do we change it? And then we'll kind of step back into some easier stuff with picture graphs and data graphs and stuff that you're probably more familiar with. So we'll give you this to practice. Feel free to go back to the video and slow down through some of those examples on that graphing worksheet if you want to. I know I flew through a couple of those. There is a new quiz tonight at 11:59 p.m. And of course, a new homework due tomorrow in class. You guys have a great day.